Vector projections. Vector resolute. The vector resolute of A in the direction of B can be expressed in any one of the equivalent forms. Okay, so it doesn't matter which one you do. Just have a look at this. There's that form, there's that form, and that form. The quantity A, B with the witch's hat, otherwise known as that, A times B divided by magnitude of B, is assigned length of the vector resolute U, and is called the scalar resolute of A in the direction of B. Example 12. It says let A equal I plus 3j, B equal I minus j. Find the vector resolute of A in the direction of B. So we'll do A over here. So this one, I need A times B divided by B times B, and then I've got B there. So we better find A times B. A times B, 1 times the 1, 3 times the negative 1, minus 3, so I've got negative 2. B times B. B times B is 1 times 1, which is 1, minus 1 times minus 1 is 1, so that gives me positive 2. So therefore this will equal negative 2 divided by 2, and I minus j is the B, which means it's negative I plus j, or we can rearrange it to j plus I. Part B. We want B in the direction of A. So we want B, A, and then, well, that's just the same as A times B, so that's just negative 2. And we want A times A, which is going to be 1 times 1, which is 1. 3 times 3 is 9, so we've got 10. And therefore the vector resolute is going to be B, A divided by A times A, and this time A, which means it's going to be negative 2 divided by 10 of I plus 3j, which means it's negative a fifth of I plus 3j. Example 13. Find the scalar resolute of A in the direction of B. Okay, now the scalar resolute is given by the rule of A times B divided by the magnitude of B. So A times B, we'll do it over here. A times B is 2 times the negative 1, which is negative 1, and negative 2, and 2 times the positive 3, which is the 6. So I get 4. And the magnitude of B is B times B, remember, which is negative 1 times negative 1 is 1, 3 times 3 is 9, so I've got the square root of 10. So if I come over here, I will get 4 divided by the square root of 10. Now, not having surds down the bottom, we can multiply that by the square root of 10, which will give us 4 the square root of 10 up the top divided by 10, simplifies down to 2 the square root of 10 over 5. Example 14. Resolve I plus 3j into rectangular components, one of which is parallel to 2i minus 2j. Okay, so we'll say let A equal I plus the 3j, and B equals 2i minus the 2j. So the vector resolute of A in direction of B, given by, just so we have the rule here, A times B divided by B, B, and then the B there. So we have A times B, which is 2 minus 6, which is negative 4. We have the b times the b, which is 4 plus the 4, which is the 8. And therefore, the vector resolute will equal negative 4 divided by 8, 2i minus 2j, which will equal negative a half of 2i minus 2j. I can take 2 out as a common factor and cancel, and I'll have negative I plus j. Now, perpendicular component is a minus negative I plus j, which equals, a we already know is I plus 3j minus negative I plus j, which means it's 2i plus 2j. Hence, we can write I plus 3j equals negative I plus j plus 2i plus 2j. And that's our resolving it into rectangular components.